Okay, welcome everybody to this video, and in this video we'll be mainly discussing the use of mates. So you should all be familiar with the precision of the mate tool here, and we've already used the coincident mate quite a lot. But in this video we're going to show you the parallel, perpendicular, tangent, coincident, or concentric, sorry, distance mate, angle mate, because those are the most commonly used mates. And we're also going to use the symmetry mate, which is also quite common. Now, to display this, I've added some random objects. This cube here is fixed on the origin, and the rest are just free to move around in the assembly space. So we can add a mate using either a point, a line, or a face. Now, the preferred method is always a face. A line and a point hold down significantly less information compared to a face. So if I were to mate this point to this point, click OK, and then if I move it around, only the point remains coincident, but both parts can rotate, or this part can rotate significantly, and it's not really fixed together properly. So it is possible to add a mate with a point, but if you have the option to select either a face or a line, this should be your preferred method. Now, let's first start with the basics. Of course, coincident, select face or point. Oh, let's try that again. This face, let's select that face, and we have a coincident mate. Now, what we can do then is select this line to add a mate, and select this line to add another mate. And we're done, and the parts are joined together. Again, by using 3 mates. And this top one is of course to mate the top cube to the origin. So you can neglect this first mate, and these were the 3 mates which we added before. So let's delete them again. Let's remove the part. Now let's add a parallel mate. So we're going to add a mate. I'm going to select this face and that face, and we're going to select not coincident but parallel. Once we've done that, the parts can still move, and the 2 faces won't be aligned together, but they will remain at the same angle. We can also select the mate perpendicular. If we were to select these 2 faces, then these 2 faces will automatically get a 90-degree angle. Now let's add a distance mate. So we're going to select bottom face and top face, and then we can enter a dimension. And we can also flip the dimension here, flip the alignment using these 2 buttons. These 2 buttons for flipping the alignment can always be used. Even when applying mate like perpendicular, they can be used as well. So these are 2 handy buttons. If you don't really like the alignment of your mate, try clicking these buttons to flip the alignment. So let's keep the alignment like this, and let's add a distance of 25 millimeters. Let's click OK again to close. Now as you can see, the distance between the 2 faces will always remain 25 millimeters. And you can see the distance mate here, the perpendicular mate here, and the parallel mate here. Now let's add some other mates to make it fully defined. And now we can move it left and right, but you can see the distance will always remain 25 millimeters. Now, because we always look at the assembly in 2D, sometimes it looks like the distance will change. For instance, if you look at it from this angle, it looks like the distance between the 2 cubes is 0. So this always gives a little bit of a strange image when looking at an assembly at certain angles. But if you're unsure, just rotate the view to get a better image. Now we can select these 2 faces with coincident again, and the parts are joined together, and next you can see the minus signs are both removed. So these are the distance mates and normal coincident mates and the parallel mates. They're pretty common, and they're pretty self-explanatory. Just by looking at the name, you will know what the mate types will do. Now let's move this back again, and let's select the triangle. Let's mate this line to this line, and mate this face to this face. Click OK. If we exit it now, we can rotate the part like this. And let's say we want to specify an angle between this face and this face. So we can go to mate, go to an angled mate, select 2 faces, and here we can once again select the angle. As you can see, if I hold down the button, the angle changes, and I can specify an angle, let's say 45 degrees. And then the angle between the two faces is 45 degrees. Click on OK, and then the component is fixed as well. So I cannot move this component now. Well, let's delete this again, and let's move it back. Now, here we have the sphere, or in this case it's called a ball, but every spherical object has no faces. So this causes issues, because if I go to mate and I would select this face and this one, the only option I would have is the tangent option, which does the same as in a sketch. It makes sure that the arc moves fluidly onto a straight line. So as you can see now, the arcs connected to the top face and they move over each other in a pretty fluid motion. So this is pretty much the only option I've got. So I can click on OK now, and then the sphere will stay connected to the top face. As you can see, it stays connected, but that's pretty much it. If I just select the face of the object, I have no other options. But we do have the option to mate the planes. So every part, this cube has 3 planes, this ball has 3 planes, triangle has 3 planes, every single part always has 3 planes. And if the part doesn't have enough planes, you can always add planes by using the add plane feature. Now if we click open the ball, you can see we can select one of the planes to add a mate. For instance, let's select this right plane and let's mate it to this face, like so. And let's select another plane. Let's select top plane, and let's just mate it to this front face. So select coincident, mate it to the front face. And now you can see the ball is still fully defined, even though it has no exterior faces which you can select, except for the spherical face, which you can only use a tangent relation for. Now, as you can see, it's fixed in position at the corner point of this cube here. Now let's again remove the mates and move this back, and let's move this cube around here. Now we're going to do a little bit something special, and let's remove these 2 objects as well. And let's also remove this coincident mate, which mates this cube origin to the origin of the assembly. So what we're going to do now is we're going to add symmetry. So these 2 parts will be separated from the origin at an equal distance using symmetry. So first thing we're going to do is we're going to make sure the 2 cubes are in line with each other. So I'm going to select a mate, and we can select these 2 faces here, make sure they're coincident. Then we're going to add another dimension here to make sure it's coincident as well. Okay. Then what we're going to do is we're going to add a mate. And let's click open both the cubes. And we're going to add a mate using an assembly plane and 2 planes from the parts, because we're going to make a symmetry. And if we want to make a symmetry mate, we always have to have a mirror plane and 2 oppositing features or entities like points, lines, faces that are mirrored. So let's select this face. This should be the mirror face. Then select the right plane here and the right plane there. We're going to click on the mate. As you can see, Solidsworks automatically snaps to symmetry. If it doesn't do that straight away, click open Advanced Mates, click on Symmetry, select your symmetry plane here, and select the other planes here. You can always click open this plus button here and select the planes as well, even if you're already in a feature like I am here. So now it adds symmetry. Oh. Well, for some reason we can't close this now, so just click on OK, then try to close it, then it will work, and click on OK again. Now if I move this component, as you can see, it stays symmetric. Now we still can move this cube up and down and left to right. And in order to prevent this motion, we need to mate 1 cube from the planes of the cube to the planes of the assembly. So let's mate the front plane to the front plane. Let's mate the top plane to the top plane. Click on OK. Now the only movement we should have left is a sideways movement, as you can see here. It's always symmetric, always from the origin, because we've made it the two parts together to be in line with each other, that they're symmetric, that they're coincident from the part to the plane of the assembly, and we've done the same for the top plane. So the top plane of this part is the same as the top plane as the assembly. Now the only thing which remains is the distance between the two cubes. So if I add another mate, for instance from here to there, I can now add a distance. Let's say it's 100 millimeters. Click on OK. And what you'll see now is that even though there's no part on the actual origin of the assembly, the entire assembly is still, as you can see here, fully defined. Why? Because the two parts are in line with each other. They are symmetric. We have made it two of the three planes. So the only motion we have left is the sideways motion. And we have halted that sideways motion using the symmetry we added and the distance of 100 millimeters. So if you want the planes of the assembly to always remain in the center of the assembly, as you can see here, the right plane is always in the middle of the assembly. So if you're making symmetrical parts, this is a very handy way to set up your assembly, because you'll always have a plane to mirror objects on one part of the assembly to the other, namely this right plane here. So in this video we've discussed distance mate, angle mates, a tangent mate, symmetry mate, and of course the very basic coincident, perpendicular, and parallel mate. So using these mate options you can make the engine and most of the other components, as well as all the components in the CSWA exam.